Hey there, in today's video we're going to be going over part 1, questions 1 through 10 from the 2016 to 2017 TMSCA General Math Test number 1. Let's do it. Alright, let's begin. Which expression below produces the least sum? Alright, so all we have to do is compute all of these and find out which one is the lowest. So let's do that really quickly. 518 plus 812, that is 1,330. 100 plus 834.6 is 934.6. 901 plus 56 is 957. 371 plus 499 is 870. 299 plus 799 is 1098. Alright, so now out of all of these, the least one is D, 870, and that's your answer. Next, 7,498 minus 3,227 equals 6,003 minus blank. This is the value we're trying to find right here. Alright, the way we do this is actually really simple. We just have to compute 7,498 minus 3,227, and let's say that gets us R. Then we have to find out 6,003 minus what? This value. We have to find out what this value is equals that R value. But there's something cool about subtraction. What we can do is, if we have A minus B equals C, that can also be written as A minus C equals B. So once we find the R value, we're going to do 6,003 minus R to get our answer. Alright, so let's do it. First, we need to find our R value. That's just 7,498 minus 3,227, which is 4,271. Now that we know that the 4,271 is equal to R, we can do 6,003 minus 4,271. That gets us 1,732, and that's your answer. Next, Teacups Unlimited buys tea bags that come in 50-pound bags. If each bag can make 1,245 cups, how many cups can Teacups Unlimited make if they purchase 6 bags? Alright, this is actually pretty simple. First off, since we're just seeing how much cups can be made with how much bags, the weight of the bag is irrelevant here, so we don't need that. Alright, so they're saying that each bag can make 1,245 cups. And they're getting 6 bags. So all we have to do is multiply 1,245 times 6. We can break this down into 1,000 times 6 plus 200 times 6 plus 40 times 6 plus 5 times 6. Alright, so let's do it. So 5 times 6 is 30. 30 plus 40 times 6. 40 times 6 is 240. Alright, that is added to 200 times 6, which is 1,200. And then we have 1,000 times 6, which is 6,000. So now we add all these up. This is 7,200. This is 7,440. And this is 7,470. And that's your answer. Next, number 4. How many 1/5 are there in the number 47? Alright, so this is actually just a simple division problem. All they're doing is 47 divided by 1/5. The reason we can tell it's division is just breaking up a number into groups. So for example, if I ask you how many 3s are in 6, that would just be 6 divided by 3, which is 2. So in this case, this is just 47 divided by 1/5. The thing is, when you divide a number by a fraction, you can't just straight up divide it like that. What you have to do is you have to turn it into a multiplication problem. The way we do that is we find the reciprocal. The reciprocal is just taking the numerator and denominator and switching it. So let's say we have A over B. When we do the reciprocal, that becomes B over A. That's the reciprocal. So what we need to do is we need to take 47 and multiply it by the reciprocal of 1/5, which is just 5 over 1. Or 5 over 1 is just 5. So that just becomes 47 times 5. 47 times 5 is 235, and that's your answer. Next, what is the total number of triangles that can be found in the picture below? Alright, this is actually a pretty simple problem. All we have to do is just count them. So there are 3 individual triangles, there's 1 large triangle, and then there's these 2 mini triangles, 1 and 2. So that's 3 triangles plus the 1 big triangle, and then plus the 2 mini triangles, which is 6, and that's your answer. Next, what is the greatest common factor of the numbers 1560 and 248? Alright, so to solve this problem, what we need to do is we need to do 1560 minus 248 first. That just gets us 1312. Now what we need to do is we need to see if this number that we got, 1312, goes into both 248 and 1560, which it does not go into either of them. So this doesn't work. What we need to do now is we need to break up 1312 into its factors. So let's do that. 1312. 1312 divided by 2 is just 656. So we have 2 and 656. Alright, so one thing we need to do is we need to just find the greatest common factor that is less than 248, the greatest factor of 1312. So 656 automatically doesn't count. So 1312 divided by 3 is not a whole number. 1312 divided by 4 is a whole number. That's 328. But that's still too big. Next, 1312 divided by 5 is not a whole number. 1312 divided by 6 is not a whole number. 1312 divided by 7 is not a whole number. 1312 divided by 8 is a whole number. That gets us 164. Alright, so now what we need to do is out of these, we need to see which is the highest factor of 1312 that goes into both 248 and 1560. Alright, so 656 and 328 are already both bigger than 248, so those don't count. 164 doesn't go into both of these either. So now we're left with 8, 4, and 2. 8 goes into 248 31 times. And 8 goes into 1560 195 times. So 8 goes into both of them, which means that is your answer. Next, the number 114 has how many positive integral divisors? Okay, so this might seem like a pretty hard problem, but trust me, it's easy. In fact, I actually have a full video just on these positive integral divisors type of problems, which will be linked in the pinned card at the top. But let's continue with this problem. So, 114. What we need to do first is find the prime factorization. If you don't know how to do the prime factorization, I have a video just on that as well, but I'll show you right here. That video will be linked in the pinned card at the top as well. Alright, so 114. So let's start off by dividing it by 2 since it's an even number. 114 divided by 2 gets 57. Alright, next. Now let's try and divide this by 2. But we can't because it's an odd number. So let's go to the next one. Can it be divided by 3? Yes, we can. 57 can be divided into 3 and 19. 19 cannot be divided by any other number other than itself and 1. That means it's a prime number. Alright, so now what we're doing is we're trying to see, is there any more numbers that we can divide that are not prime? 2 is a prime number. 3 is a prime number. 19 is a prime number. So there's no more that we can do. Now we need to write the prime factorization. The way we do that is we write each of these numbers, 2, 3, and 19, and we put them to the power of the amount of times they occur in this factorization. So 2 only occurs one time, so we put it to the power of 1. 3 only occurs one time, so we put it to the power of 1. 19 only occurs one time, so we put it to the power of 1. Alright, so now when we multiply all these together, we get our prime factorization, which would end up with 114. Alright, but now what we're not looking at is the numbers. We're looking at the exponents. So let's take all three of these exponents, 1, 1, and 1. To find how many positive integral divisors there are, we need to add 1 to all of these exponents. So that leaves us with 2, 2, and 2. And now we just multiply these numbers. That gets us 8, and that's your answer. Next, today is Tuesday. What day of the week will it be 45 days the day after tomorrow. Alright, so this problem might seem confusing. That's because it is. Alright, this problem is actually worded wrong. They made a mistake while typing this out. It's supposed to be, what day of the week will it be 45 days after the day after tomorrow? Alright, so let's just insert an after right there. Alright, so what we first need to do is we need to find out what the day after tomorrow is. So if today is Tuesday, the day after tomorrow is just the day after Wednesday, which is Thursday. Alright, so we're starting off with Thursday. Now, what we need to realize is how many days are in a week. There are 7 days in a week, and we have 45 days after the day after tomorrow, which is Thursday. Okay, so what we need to do is we need to do some division. We need to do 45 divided by 7. 45 divided by 7 is not a whole number. It gives us a remainder of 3. So in fact, it's 6 remainder 3. We can ignore the 6 for now because all we're looking at is the remainder. We can just say that we skipped 6 weeks ahead and we're back on Thursday. Now, after Thursday, there's 3 days left. So that would just be Friday, Saturday, Sunday. So after Thursday, 3 days after Thursday is just Sunday. And that's your answer. Next, 5.4 times 20 equals what in Roman numerals? Alright, so I have a full video just on Roman numerals. But let's continue with this problem. That video will be linked to the pin card at the top. So what we first need to compute is 5.4 times 20. So that's just 5 times 20, which is 100, plus 0.4 times 20, which is 8. So that's 108. Alright, now there's two things you need to know about Roman numerals. First is the actual digits themselves. So we have I, which is 1, V, 5, X, 10, L, 50, C, 100, D, 500, and M, 1000. Alright, one more thing you need to do is the 4 and 9s rules. So what that is when you're writing a 4 or a 9, right, you wouldn't write it as I. Or with a 9, V, I. Instead, you would write it as 1 before the next number. So in this case, it would be 1 before 5, which is I before 5. Or with 9's case, it would be 1 before 10, which is I, X. And the same thing happens when you continue up in scale. So 40 would be 10, which is X, before 50, which is L. So X before L. 90 would be 10 before 100, which is just X before C. So those are the 4 and 9 rule. Now that we know that, we can solve this. So we have the number 108 to convert to Roman numerals. So let's break it down into 108. So 100 is just C, and 8 is just V, I. So now we just add these up to get C, V, I, and that's your answer. Next, 3.5 times 10 to the power of 5 times 2.4 times 10 to the power of 6. Alright, so there's two things here. When we have a multiple multiplication like this, we can just write this as 3.5 times 10 to the power of 5 times 2.4 times 10 to the power of 6. Alright, so right here we have two common terms. We have the tens and we have the numbers. So we can separate them to make it 3.5 times 2.4 times 10 to the power 5 times 10 to the power 6. Alright, so let's do this. So first, 3.5 times 2.4, that is just 8.4. Next, 10 to the power 5 times 10 to the power 6. Alright, so it's the same base number with just different exponents. So when you're multiplying the same base number by itself with different exponents, all you have to do is just add the powers, which is 10 power 11 in this case. And just to make sure we got this right, we need to check that this 8.4 has the same amount of digits as these two original numbers, which it does. So that means now we have our scientific notation by doing 8.4 times 10 to the power of 11, and that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, please make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.